Okay, welcome back. We were talking about, in the last video, we sort of looked at some of the patterns in temperature and sort of those cycles of glaciation during the Pleistocene. I want to look at what the effect of some of those cycles have on the areas that were not covered by glaciers. So, the entire Earth, even though the glaciers were expanding and retreating over large portions of land, not the entire Earth was covered. And so what was going on in some of those places that were not covered by glaciers? Let's take a look at that. So there's a few sort of trends here, changes that are impacted by these cycles that were going on. So there's temperature and precipitation trends. There's micro and macro climate changes. There's large-scale aridification, and there's fluctuations in sea level. So let's take a look at some of these. As far as temperature goes, reconstructions of global temperature show that during the Pleistocene, most places were much cooler. And so if you look at this global map, this color sort of indicates what the temperature was in the Pleistocene relative to what it is now. And so negative numbers mean um, and the colors associated with them mean that the temperature was cooler during the Pleistocene than it is now. And basically, if it's positive, just this end right here means that it's cooler now than it was in the Pleistocene. Sort of a weird color scheme because there's red indicating cooler temperatures. But so negative numbers mean it was cooler in the Pleistocene, and pretty much the entire map is covered by colors that are associated with negative numbers. So pretty much everywhere the overall climate was cooler during the Pleistocene than it is now. And if we look at precipitation, it's a similar sort of trend, maybe not to the same extent, but the patterns are really similar. So negative numbers mean that it was drier. There was less precipitation in the Pleistocene than there is now. Positive numbers mean there's more now than there was in the Pleistocene. So again, most places you're seeing less precipitation during the Pleistocene. And so what's going on is that the most of the moisture is getting locked up in the glaciers. And I'll come back to that in a second, but basically the takeaway here is that the Pleistocene climate was much cooler and drier globally than our global climate is now. Something interesting happens if you look at some of the more macro and macro not on a global scale, but sort of a continental scale, and then micro climate scale. So first of all, glaciers create this moderating climate, microclimates near the 2 to 3 kilometer high edges of glaciers by adiabatically warming the air. So if you're right next to a glacier, if you remember back to when we talked about, mountains and adiabatic cooling, when air gets forced up a mountain, we talked about how the reverse happens when air gets forced back down. The increase in pressure causes adiabatic warming. And so the air warms back up. And so there was this moderate sort of climate right next to the glaciers where you get this warmer air, simply sort of because of the physical mechanisms of it. So that was sort of an interesting thing going on, where you might have a warmer climate even though you're right next to this giant block of ice. Something that happens on continental scales, they can cause major changes in prevailing winds and the trends in prevailing winds. So over North America, you had this massive ice sheet, and you had this jet stream that was pushing, and it sort of created this cyclical, circulating air pattern, and ultimately pushed dry air over the southern portion um, of this ice sheet, sort of pushing that dry air west over the western and Pacific Northwest. Something else that happened is sort of the saturated air was getting pushed a little bit further south from the westerlies, and so you had this really wet, saturated air being pushed over basically what is the Southwest, which, as we know now, is basically dominated by desert. In the Pleistocene, received a lot of precipitation. So kind of an interesting dynamic there. Something else that was occurring, so because at the global scale, because glaciers reduced evaporative input of water into the atmosphere, they often coincide with these periods of global aridification and ultimately the expansion of deserts globally. And we definitely see that during the Pleistocene. So in past is the dark green here, and then the present is in the lighter green. We're looking at the distribution of sand dunes, basically desert-like environments. And in a lot of areas, it was a lot more expansive during the Pleistocene than it is now. And basically what's going on there is what we saw with the precipitation figure. Lots of moisture in the atmosphere that might be in the atmosphere might be distributed through precipitation. It gets locked up in these glaciers as they expand. So as all this ice, all this water gets locked up as ice in glaciers, there's less of it, to move around in actual global systems. And so you get less distributions of precipitation, and that coincided with this expansion of desert-like environments. So it was a cooler environment, and it was a much drier environment during the Pleistocene. Something else is the changes in sea level. And so glaciation during the Pleistocene lowered sea levels by about 100 to 135 meters, below their current levels, which is quite a bit. So what you're seeing here is, different areas, as far as Europe and sort of Siberia and Alaska, that connection, Australia and Indonesia and kind of area. What you're seeing is that in the light blue, that was all land. So the sea levels were much lower, so much more land was exposed during this time period. And so there's lots of connections, or there were lots of connections between areas that are now isolated. And so all of these areas, Siberia and Alaska was basically this thing called Beringia, like one big landmass pretty much. Australia and New Guinea were connected, and the Philippines and Borneo and Sumatra, and these areas were all connected because the sea level is so much lower. And you can really, I think, knowing what we know now about dispersal and things like that, you can imagine the implications that this is going to have. Like organisms can now move between these areas, connected areas that are isolated now were not isolated in the past. So there was gene flow, there was migration, there was dispersal, and all sorts of different dynamics going on that are no longer going on, at least for certain types. Like once the sea level rises and these are isolated, that really changes what types of organisms can move around, and then things become isolated that weren't before. So definitely has some biogeographic implications that are pretty clear there. In general, sea levels were much higher in the period before the Pleistocene. So that's what we're seeing here. This is the Phanerozoic, which is 590 million years ago up until 6 million years ago. And basically, you're seeing how much higher the sea level was compared to present. But if we go to during the Pleistocene, which is this figure here, it switches. Basically, here's present sea level, and most of the time the sea level is lower than what it was, or than what it is now. And you can see those sort of, this is sea level, but once you get into the Pleistocene, you can see these interglacial periods where sea level, this is sea level, not ice volume and not temperature, but it mimics those other figures that we were looking at where you see these up and down cycles. And even on shorter time scales of thousands of years, you see it as well. If we were to look at something more modern, here we're looking at literally, the 1700s up until relatively recently, we're seeing a global increase in sea level and a decrease in sea ice. And I think, obviously that's anthropogenic climate change that's going on, where the climate is warming and ice is melting and sea levels are rising as a result of that. So ice is melting and sea level are rising. If you've watched the news, hopefully that's not new information for you, but it does, it's in that way, it's related to the changes that happened in this way. Like we can see the direct impact that temperature has on all of these things, from sea level to ice levels and ice volumes, and all of those things sort of becoming interrelated there. One other interesting thing before I wrap up this video, during the most recent glacial retreat, sea levels rose more rapidly than land depressions. So you get these shallow seas. So what happens is, like, as the glaciers recede or expand over North America, they're really heavy, so they're sitting on the land. They create these depressions in some areas where the land, it gets like pushed in basically, and then when the glaciers melt and retreat back, you have these depressions that are left in the surface of the earth, and eventually they fill in for the most part, but not right away. And so there was these basically connected seaways. You get this sort of really shallow um, corridors, like shallow marine sea, that was over this small portion of northeastern North America. And what we can see as the result of that are these disjunct populations of these, so let's see, euphorbia or some water species or aquatic species, where you see these disjunct populations. It don't really make sense unless you understand that this was once all connected. So I'll come back to some of the biogeographic responses to some of these climatic changes that we've been talking about, but that's one interesting one that's specifically related to the changes in sea levels. Okay, I'm going to stop this video and then we'll pick up right with the next video. So take a little break here. There's no reading for this between these two. So I will see you in the next video.